Hello everybody. In this video we will discuss SN2 reactions of alcohol. So let's do a quick recap. What is an SN2 reactions? So S stands for, we got our substitutions, and then N stands for our nucleophile. So nucleophile will substitute a group, and 2 stands for bimolecular reactions. If you have forgotten about what is a bimolecular reactions, make sure you watch one of our previous video that we had before, where we discuss unimolecular and bimolecular reactions with the SN1 reactions when we discussed. Okay, so let's begin with here. What exactly is happening in these reactions? So you have a leaving group, OH, that's going to be substituted by a nucleophile, which is Br minus, and we are basically replacing OH with Br. So let's look at the mechanism, how it is exactly is happening. So you have OH alcohols, which has lone pair, and then we have HBr. So we know that the lone pair on oxygen will attract the proton from HBr, and because Br is electronegative, it will take away those two bonded electron towards itself, and as a result you will create something like this. And plus Br minus. All right, so now if you notice, oxygen has 3 bonds, and every time oxygen makes 3 bonds, it has lost 1 electron because it gave away electrons. So in this case, it should have a positive charge, not partial, it should have a positive charge, and that positive charge has to be neutralized in the next step. So that's exactly what is happening here. So if you want to neutralize it, there are a couple of ways you can neutralize it. It can get rid of its excess proton, like bringing back these electron here. There are 2 electrons here. It can bring them back. So if it does, that's basically going backward, right? So that's the same thing that we had before. So that's why you see an equilibrium signs. Okay, so instead, let's move forward. So what we're going to do here is we can neutralize it by removing this bond here. So if we do that, what's gonna happen? I'm gonna draw all the carbon here. So we got CH3. This is not correct, but I'm showing everything related to the carbon atom right there. Okay, so we got OH2 plus. That is our water right here. This is our OH2 plus. So let's see what happened. So let's say this group goes out. Okay, so let's say this group goes out. So the bond is broken and this group goes out, and then this group goes out. So what happens to the carbon atom here? So you created a carbocation. Now what type of carbocation is this one? Primary carbocation, right? That is our primary carbocation. And we know primary carbocation is not stable at all, right? So this mode of actions will not happen in SN2 reaction. So this will not happen because you are creating a primary carbocation which is not very stable. Instead, what's going to happen is, let's go back. I will bring this back here so that you can see what we are doing here. Okay, so instead, what will happen is you will never create a carbocation, but you gotta break the bond. You gotta break the bond. So as you are breaking the bond, as you're breaking this bond, the nucleophile Br minus will simultaneously attack the carbon atom right here, the primary carbon atom right here. So again, let me recap. As you're breaking the bond between carbon and oxygen, Br minus will approach from the opposite directions. That's important. SN2 reactions always happens from the opposite direction. So the nucleophile is coming from the opposite directions to attack the same carbon atom, so that the carbon atom actually never be empty. Like it's never going to create a true carbocation, but the attack and removal will happen simultaneously. So let's try to draw this one. So I will remove this one to this one. So we'll create some space here. Okay, so now what's going to happen is your Br minus is attacking on the carbon atom right here, and the leaving group is going there simultaneously. This is the rate determining step. All right, so this is our rate determining step. So let me redraw it nicely. Okay, hopefully arrows are better. Okay, so in this step, you noticed how many molecules are involved. So you have a molecule that is Br minus, well, how many? So this is one of them. And the other molecule that is involved is this whole thing, right? So this whole thing right here. So you have two units that is participating in this reactions. And when two things are participating, that's our bimolecular reactions. This is the rate determining step. So this is the rate determining step of our reactions. And because there are two units are involved, one on the left, one on the right, so this is our bimolecular reaction. So this is this attack that we saw here. This is SN2 attack. So that is SN2 attack by a nucleophile, and it always happens from the opposite side. It happens from the opposite side of the leaving group. So whatever side the leaving group is, it's going to happen from the opposite side. So if the leaving group is pointing to the up, then the attack will happen from the opposite, which is up. Opposite would be downs. Okay, so our product would now be Br and plus water. So it's basically replacing OH with Br, but it is doing through SN2 reactions. So we could do the same thing with the chlorine. However, chlorine needs a little bit of extra help. So chlorine need a catalyst, which is zinc chloride, and chlorine is not going to be able to create a decent leaving group with, so it will need a little bit of catalyst, which is zinc chloride, but the end product is the same, where your OH is being replaced by our chlorine. So it will need the catalyst. Okay, let's stop the video here.